Hello everyone, this is Amrita Dasyam and we are here to present and discuss the paper State Feedback Control for Intelligent Traffic Light Systems, which is a research work by I. Tung and M.T. Solomas. To get started, this study deals with traffic light control systems and they focus on improving the traffic flow at the intersections, especially in the metropolitan cities where traffic jams are one of the major issues. In general, traffic light control systems are of two types, conventional and closed-loop adaptive. Conventional control system as fixed cycle time. Cycle time is a complete sequence of traffic lights, green, yellow, and red. Closed loop adaptive uses the traffic flow data collected with the sensors like cameras and detectors to determine the traffic light times. In closed loop adaptive system, the traffic lights can be regulated with green light time, cycle time, and lost time. Lost time is the time interval between the changing lights. The short and long periods per green light can change the traffic density. Therefore, it is essential to determine an efficient green light time to keep the traffic flow smooth and decrease the wait time of incoming traffic in other directions. With this motivation, this paper's objective is to determine the efficient green light time using state feedback control in traffic light systems. They also consider the cycle time with a major focus on reducing waiting times and CO2 emissions. Further, the authors compare the proposed method with fuzzy logic and fixed-time traffic light controllers, which are discussed in detail later in the presentation. Coming to the simulation model, this paper considers a four-way intersection with four entrances and exits. As seen in the figure, the four roads have two lanes each, and each road is named after four main directions: north, south, east, and west. The traffic lights have two phases. Phase 1, the traffic is directed straight only in the east-west bound. Phase 2, traffic is directed straight only in the north-south bound. The sensors placed in the entry and exit areas of each road determine the number of vehicles. Further, the control system was designed with the following assumptions, main ones being number of vehicles in phase 1 is greater than number of vehicles in phase 2, minimum green light time was 6 seconds, maximum green light time for FLC and state feedback was 100 seconds. So that was a brief overview of the simulation model. Here now is Adit Shah, my team member, to talk about the methodology.
In the methodology, we start with the conventional traffic control design. So the traditional traffic control system has a fixed cycle time, which means that the vehicles coming from east and west directions has a green light on for the first 50 seconds, and then the green light is on for the 50 seconds for the vehicles traveling from north and south direction, and then the cycle keeps on continuing. The dynamics of the system is derived in discrete time. The state equations that are derived for the state feedback control design uses two state variables. The first one is Qi and the second one is Wi. Qi is the sum of vehicles coming from east, west, north and south directions, while Wi is the sum of waiting times of vehicles coming from east, west, north and south directions respectively. T is assumed to be the sampling time, Di is assumed to be the number of vehicles leaving the intersection, and small qi is the number of vehicles entering the intersection. With those, we also have an input, that is the input signal S1 and S2 for east and west directions and north and south directions respectively. To get that, we model and get A, B, and C. The dynamics of the system is closed-loop adaptive and time-independent. Thus, Ackermann's formula is the useful control system design tool to solve the state feedback control of invariant time systems, especially in such a high-grade system. Here, alpha c is a characteristic polynomial with all the desired poles and eigenvalues. So we do get the characteristic equation of feedback system by using the determinant and setting it equal to 0. Ackermann's formula for the gain matrix K is given by the equation. Since the desired reference signal was 0, the green light time for east and west bound was calculated by the formula shown as S1 of n equals to the gain times the x of n. The fuzzy logic control design (FLC) accurately simulates the human factor of the traffic control system. There are two inputs considered. The first one is total number of vehicles at the intersection. Second one, NVD at intersection, which represents the difference between the sum of number of vehicles coming from east and west and number of vehicles coming from north and south, which generates to the output according to the current traffic conditions to determine the green light duration, and additionally a green phase is recalculated every second, which makes the change in the green phase time dynamics. Now handing over to Yao Chen for the conclusion and results.
Alright, in this article, the outcome formulation performing closed-loop adapting feedback controller. Other two is Fossey logic traffic light controller and the fixed time traffic light controller is previously described a part of the comparison in this simulation. The simulation is done by the simulation of the urban mobility, as we could see on these two graphics, and the Ackermann formulation had dramatic improvement on the average speed of the car, and total waiting time of the car had to wait on intersection had decreasing by 3 of 4. Is dramatic changing compared to the all the two traffic light controller. And in this part is accumulating CO2 emission output versus full vehicle per second. As we can see, the Ackermann formulation have the much more better result to reducing the CO2 versus compared to the rest of the two methods. In this study, main goal is to determine the optimal time duration of the green light and red light at the intersection in very traffic condition by using the state feedback controller in intelligent traffic light system. As the result prove the state feedback controller is performing better than Fossey logic controller and fixed time controller. And the advantage of using the state feedback controller is have the lowest waiting time, highest average speed of the car, and reducing the CO2 emission output. However, the weather condition and sensor never be considered a part of the problem. Simply just making assumption, assume they are not affecting at all. Also, we see the increasing in the total waiting time in the case of the heavy traffic pass from the east to the west. Consider the traffic just automatically assume this condition, and also the complexity of the intersection never simulate any increasing the challenge to the intersection complexity. It is really simple four-way intersection. Also, the cost associated with the if we decide to replace this to the from the old commercial to the new one. Thank you for your time to listen our presentation. Thank you so much. Bye.